And here's the diagnostic Nanotyrannus tooth I mentioned. It's double serrated. It has a serrated edge here, serrated edge here. It's a little bit different. The T-Rex teeth are a little bit different than this guy. And this one has more teeth. So I'm of the opinion that it's a separate taxon. But a lot of people don't think so. So that was the only element that was negative. But would it surprise you to know that we found nematodes in it? I kind of gave that away a second ago. But this is not Nanotyrannus. This is a photograph of Triceratops horn, the original horn that goes all the way back to 2012. So we thin sectioned that also. And what do we see here, class? That's bone. What are the dark dots, class? Cells. What's the black stuff, class? Clot. What's that? That's a nematode. He's feeding. His mouth is actually on the clot. You can see all the internal structure in here. Now, he's preserved in this slide, which means when we put our specimen into preservative, you've heard of formaldehyde. We call it formalin. Paleontologists don't do that. They don't put their specimens in formalin. We put everything in formalin. And that's why I think we're seeing and finding the structures that we are. But this was a nematode that was feeding at the time that I put this bone into fixative and it froze him in place. I can even see his internal organelles. This is published now. And in the same paper, we referred to a paper from Brazil, brand new paper from Brazil, where they were photographing the same specimens and calling them blood parasites from the original dinosaur. Those are not blood parasites. Those are opportunistic worms that are feeding on the graveyard. There's still meat enough in those bones, and they're making babies. Now, I slipped one over on you. This is Triceratops, but I slipped this picture past you without mentioning the nematode that's in the center of that canal. So that's Nanotyrannus. There's a nematode. And we've also found them in Montosaurus. But you may have seen this picture before. This is a low-power magnification photograph of a large thin section, and there are 21 nematodes in this bone alone. So, and then I went through a couple of other slides and photographed actually 65 individual different worms of varying sizes. Why? Because they're making babies. You know, there's large ones. When I did my parasitology work, the worms that I studied pumped out 300,000 fertilized eggs a day. Yeah, imagine that. So they're taking advantage of the meat that is still in there. This is a world-first discovery, that there are living organisms inside these bones consuming the flesh, worms. Now, other studies have shown bacteria. In fact, we were discussing this morning. One of the papers out there shows that the bacteria that are growing inside of these thriving microbiomes, they call them, inside the bone, thriving microbiome, are different from anything found in the soil. I'm stealing your thunder. I'll shut up now. You got to come back for the second lecture today. Keith is going to wow and zow us. But no, these are ecosystems that are supporting nematodes. Who knows what else? And it's borne out in several of our experiments. Now, this is what they look like in living form. Here's their progeny. You see they're much smaller. But here's the Nanotyrannus, thin section, the clot, nematode in there. And we dissolve these bones, as I've mentioned, and we pipette those solutions on the slides, and here's a nematode that came out of that dissolving experiment. So I actually flushed one out of the bone while I was dissolving it. What we're trying to do is encourage them out of the bone. So we're learning how to plate out auger plates to put these specimens on and to coax these nematodes. Can you imagine if we got a picture of worms crawling out of a dinosaur bone? Would that make the cover of a journal? If I had a journal, it would make my cover. I don't know. Maybe nobody's interested in that, but I sure am. What does it mean? It means these things can't be that old. If organisms are still thriving and they're eating this stuff, They can't possibly be old. So we're just kind of proving the concept. A lot of work needs to follow what we're doing. We're just opening doors. All right. This is Ruth. No, that's Ruth. No, this is Ruth. This is Edmontosaurus that they named after my lovely wife up in Montana, the Base Ranch. This is a 17 or 18-foot long vertebral column of Edmontosaurus. And I think we have the jaw here. Jawbones have the largest nerves in all of these organisms. And so we are really hunting for a jaw because we'll probably get some fat nerves out of that one, real fat ones. But we've already worked on one of the ribs. They're pretty well degraded, so I'd hope to have a specimen, a large one that we could bring for you to handle, but they're pretty friable, so we're still trying to work on that. But we've made thin sections already. And so we've cut this bone, and we have found, again, the clots that light up. So these clots light up in the UV. But also we found something interesting here. And in regular bright field microscopy, you don't see much structure. You see sort of round lobes, these roundish, sort of stubby lobes. I'm wondering, what is that? And when I lit it up with UV, it revealed structure inside, so you can see more detail on these round lobes with structures inside of them. Another thing that's interesting is that they're in the bone, so they're tunneling into the bone, whatever these are, and they're emanating from the clot. See that? I have another picture that shows this. Let me skip over this one. But here's clot. All the dark stuff is clot, right, class? All the dark stuff is clot. Here's clot. Look how it's coming out of the clot into the bone. See here? Look how it's coming out of the clot into the bone. You see that? It's coming out of the clot into the bone. So it's actually going into the bone. It's probably going after the cells in there. But what is it? Well, we decalcified some of this partially, which means we put it in that weak acid and melted away some of that bone material. And here's a scanning electron microscope picture of these very same structures with the bone taken away. These are all cells, all this fine stuff. Here's cells along here. The fine arrows are pointing to cells. The thick arrows are pointing to these fungal hyphae. This is a fungus. So we think this is a world first. We searched and searched. Maybe you guys can find a paper that talks about living fungal infestation in dinosaur bone. These are alive. I mean, to have this kind of structure after we put them in the formaldehyde and took away all the bone. Imagine this slab of concrete. Imagine I erase the concrete and all you see is the plumbing in there. That's literally what we've done. And you can see these rounded bulbous structures. So these are, in my estimation, a fungal infestation into the bone that still has protein in it, and that's why they're going after it. So you see it here. Now these are human bone fungal infestations. So this is in the literature. So you see these round structures, the same kind of lobed structures that we saw in our preparations. Same kind of lobed structures. So we think that's a world first. We're anxious to publish on that. But how else can you be sure that these are fungal hyphae? They're called hyphae in plural, hypha, singular, because they have cross walls in them. You can apply a special stain and use a fluorescent microscope, and these cross walls called septi show up very vividly. See that? So that was a living fungus that I grew on a piece of bread. It's really easy. Just wet a piece of bread and put it in your sock drawer and close it and don't go there for a month. Mom, I'm doing an experiment. Dr. Mark said. And take that stuff out and put it under your microscope and stain it with this stain. It's called mycoval. Well, I did that on the bone. And so here's my result. What is this, class? That's a canal with a clot in it. Look at how it's going down into the bone. See it? You see the depth of the clot. This is all bone mineral. And here's these structures over here. And I stained it with that microvalve. Look at, it may be hard to see from where you're at. You can come up later. I think I identified the septi in living fungus that's growing in dead dinosaur bone. To be continued. So that's kind of our hottest stuff. This just happened last week. And it's like that. We bring bones home from the days we start thin sectioning them and decalcifying them, and it's like Christmas morning. Every time we look at the preparations, we find something new.